Welcome back to episode 5 of Stuff I Learned
in the House of Bamboo.
If you looked at my old school report cards, a common theme would emerge. Easily distracted, disruptive, and disorganized. Unfortunately, I didn't really break this trend until I was about 25 years old. I'm not a big fan of taking responsibility for my own actions, so instead, let's blame a brain region. Robert Sapolsky says, the frontal cortex makes you do the harder thing when it's the right thing to do. This is the most recently evolved part of the brain, and its complexity in humans is what separates us from our primate cousins. At the front of the frontal cortex is the prefrontal cortex. This is the brain's decider, and doesn't fully mature in humans until their mid-20s, which would explain a lot of my adolescence. Professor Jonathan Cohen says the prefrontal cortex gives us the ability to orchestrate thought and action in accordance with internal goals. Damage to the prefrontal cortex disrupts the ability of animals to act in pursuit of a future goal, leaving them at the mercy of their environment. The prefrontal cortex is a network of neural circuits that gets inputs regarding sensory information and has outputs generating motor responses. It's also in constant contact with a range of subcortical structures that process our internal information, such as motivational states, hunger, and tiredness. The prefrontal cortex then can be considered as a venue to process information from all brain regions. During learning, reward-related signals like dopamine act on the prefrontal cortex to strengthen neural pathways that lead to desired outcomes. I'll try and explain this. You take a monkey and put it in an enclosure with a rock, a shell, and a train. Now, the rule is every time the monkey passes the rock to the researcher, it gets a bit of cucumber. But the monkey doesn't know this, so it explores. It pushes the train, kicks the shell, and then eventually takes the rock and gives it to the researcher. There you go, buddy. The monkey gets a hit of dopamine in response to the reward, and its prefrontal cortex can now start piecing together the neural map that led to the goal, cucumber. Our cognitive control results from the prefrontal cortex sending excitatory signals to the relevant brain structures to solve a task. For example, in our visual cortex, neurons compete with each other for activation whilst inhibiting one another. This gives our vision contrast, depth, and focus. So, for our monkey, it sees a train, a shell, and a rock. Corresponding neurons in the visual cortex recognize train, shell, and rock, and this information gets sent to the prefrontal cortex. If the monkey is hungry, the prefrontal cortex, aided by brain systems for memory, can recall that giving the rock led to the cucumber. So, it wants to boost the neural signals involving the rock. It does this by sending those neurons excitatory signals. This boosts the relevant neural circuits while suppressing others, leading to the monkey focusing on the rock. This focus mechanism can be shown in a famous psychological experiment. Count how many times the players wearing white pass the ball. Well done if you got 13. But did you see the moonwalking gorilla? You probably did, but around 50% of people miss it. You might have missed it because your goal was to count passes, so your prefrontal cortex ensured focus on this was boosted and other information inhibited. Using our prefrontal cortex requires lots of energy, so using it for every day-to-day task is unsustainable. To solve this problem, we tried to make some behaviors automatic. This is why we are creatures of habit. So, how do we form habits? Let's go back to Gerald, the monkey. When he was first exposed to the rock-train-shell combo, he did some exploring, before realizing that handing the rock to the researcher resulted in food, which gave him a dopamine hit. This time, it's different. Now just seeing the rock causes a small hit of dopamine in his prefrontal cortex. It, in turn, sends excitatory signals to neural circuits that will help the monkey acquire the rock. The monkey moves towards the rock and gets another hit of dopamine. The monkey picks up the rock. Dopamine. Gives it to the researcher. Dopamine. And he achieves his goal. Dopamine. With repeated use of these neural pathways achieving the desired goal, they become established. The behavior becomes automatic, independent of the prefrontal cortex. This is what people say practice makes perfect, or he's in the zone. You've perfected something to the point that you don't have to think about it. I guess if there's anything to take away from this video, it's that mastering something means you can think less whilst you're doing it. If you want a behavior to become automatic, you have to repeat it again, and again, and again, so that when it comes to game day, you don't think twice.